Okay, so theoretically this is streaming now, and now I just need to figure out where and how that is happening. So let's go back. Channel content, there is one. Okay, I'm live. Next. So right now the purpose of this is that I'm just recording what I'm doing while I work. Um, if anyone happens to be on while I'm working on this, feel free to post comments. I might see them, I might not. I guess I can leave that up in the background. No, I want to see the comments. I don't even know how to do that. I don't stream very much. All right. Okay, I've got streams up. That's muted. Good. Next, I need tasks. So the task that I'm working on is for Vigilante Racer. And here we go. So in this one, I want freight to be able to follow me. Let me stop this. And I have over here some freight, and I don't have the truck or the train system up and running yet. It does seem I'm going to go with a train system instead of trucks, but not positive on that yet. Okay, so anyway, it's all anti-gravity. Here's one of the cubes, and then I'm supposed to knock this off. So when I play, why did it need to import assets for that? I can knock the cubes off, and they align to the gravity of the vehicle that it was knocked off of. Now, my objective at this point is I've knocked the freight cube off of the truck that's carrying it, and now I want to be able to take it away. So basically in the game, I want an action key. When I press the action key and I'm near one of these free freight cubes, I should be able to grab the freight cube, and it'll just basically hover behind the car. I'll only be able to have one of them. All right. Now let me go back to the task and see about any other details. Press the action button, causes the freight to follow. Follow means the freight will be picked up by the car, just moving behind it. I'm going to put in wobbly. I want it to be able to shake around, and it's going to kind of follow as if it's got its own system to move around. The freight effectively does get its own gravity, but in the game, in the I'm not sure what the term is, the lore of the game. The freight cubes are supposed to be able to move around a little bit on their own, but not a lot. So the truck brings it most of the way to its destination, but then it can kind of move around with a little bit of guidance. All right, so let's see. Moving behind wobbly. So as the car moves around, I want the freight to follow along it. And as it turns, it should turn with it, potentially bumping into things. Okay, the freight gets physics, no gravity. It tries to lerp towards the anchor point on the car or truck, and on action when holding, that needs a comma, cause it, so when we're carrying the object and we've pressed the action button again, it should cause the current freight to release from the anchor and gain the current car's gravity normal. So the freight is being carried behind the car, and let's say this is up, so that's down. That's this gravity normal pointing that way, the force of gravity going that way or that way, whatever way the car is on. Then when I let go of it, that cube is supposed to fall that direction. Thank you. All right. At some point, maybe I'll get a proper streaming setup and actually have stuff show up in here, or have like the text show up on the video feed while this is being recorded. All right, on action. When holding the cause freights a car, we want the car's current gravity normal to be applied to the freight, so it's going to drop. Okay, so now we currently do have that code working against the car that it's operating against. So inside of here, where is that? We got the car, we've got the freight inspector. We identify the car, and this grabs the gravity normal when it gets released from that. Now I need an action button. Okay, so let's put a couple steps in here. This should probably be its own script, so I'll create a new script for this. Just go scripts, create behavior, and this one is freight. We want car action. I'll go with that. Car action. I can change the names later. Now, where is... I want this information. Working on freight follow. All right, so I have my notes in here. Working on freight follow. We want the action button. So we need an action button. Oh, what was the term? I have it in car driver. Input action. Input action, and this is the action input. Great, that domain term has some very clear overlap. Needs to stay on top. All right, so we have the action input. We are also going to need to know the car because we have to get the gravity normal off of it. So public car, sure. We also need to know whether or not we're holding freight. So public, and the freight has its own script, freight. So public freight, freight. Public input. What do we got next? Freight. Probably misspelling that. Isn't it IE? No, it feels weird. Like weird is also E before I. There's so many words that go E before I. I before E, unless you're weird or freight or a variety of other things that could fit that term. How do you spell this? Am I doing this right? This is not very important, but the word, I just feel like I'm saying it wrong. No, I'm saying that right. Yeah. E before I after R in this case. All right, public freight. So we've got the items that I need. Now I need to respond to the action. What did I do for that one? That was, I enable the actions. Wait. Oh, I'm just reading the value. No, in this case, I want an input. This is going to be a button. There's an event that I can usually do for that one. Oh, Alt tab doesn't work for this. I need car action. Public void update. So inside of here, respond to the action event. So no, not in the update action. This should be on start. Public void start. Okay, so now JetBrain Rider trial. Trial? Wait, didn't they? Aren't I on a free setup for this? Or is it just automatic? Yeah, I'm on the free one. They must have put me onto commercial or something or ultimate to begin with, just as an experiment to see if I like it and I'm willing to pay for it. All right, so public start. Yeah, in this case, I want to react. So action input this dot action input dot events. How do I respond to an event in this? Oh, there we go. Yeah, pressed was pressed this frame. Now what do you want? What type is this? It's a Boolean. Oh, I hate pulling. There's got to be an event. Okay. I'm going to do a search on this one. Unity, C Sharp, input action, React, observe, button, click, on click, action. Okay. Yeah. Now see more, sure. Not what I'm looking for. This is with the input action. No, I want the new Unity. Okay, there. This one's using the new one. Let's try that. How do I expand you out? That's not expanding it out. On click, add listener. Is there a term called on click in here? No. What are you reacting to? Target button is a button. Trigger action. Okay, how do I set trigger action? Got performed. Okay, thank you. Callback context, and in this one I should have a name. On action click. Now, what else do we have? On action click, we got that information in there. All right, so right now we have click the action button. If we have the freight, we need to release it. In this case, we're also going to need an anchor. We need an anchor so the freight has a spot to follow. It's the similar plan. It's a similar plan to how the trucks are going to drive. In order for a truck to make a 90-degree turn, a semi to go up a wall, I have to have space between the different elements of it. So as it's chained across, first the truck will go, and then while it's going, it has to have space for the next car and its freight to get uh, to reach the wall, or for it to get out of the way before the next one reaches the wall, corrects, and follows. Okay, so we need to be able to release it. If we have the freight, we need to release it. If we don't have freight, we need to see if any is close by. Now, in the game, the action button is supposed to have multiple things that you can interact with. It'll be operating against UI. It'll be operating against the freight. It'll be operating against starting a race. So because that key has multiple things, it means I can't just look for freight. I need to look for something more universal like action. However, even though I'm going to be doing that, I don't need to solve that problem yet. It's not part of the task that I'm on. I'll wait until I'm on a task where I'm using multiple points of this information before I start building for it. I don't believe the architecture will gain anything by me trying to attack it now, aside from taking longer to build this one. All right, if we don't have freight, we need to see if any is close by. All right, how do we detect that we don't have any? That is going to be freight, if freight is null. If freight is null, we don't have any. So if we're going to say bool has freight equals what is that? Freight. I wonder if that works. What is this? So you can do an if statement like if freight, and if it's null, it returns a false. If it has a value, it returns true. I've never actually tried this before. Bool freight equals freight. So in this case, theoretically, it should just return true if it's there, null if it's not. Never tried it. But this one doesn't complain about it. Ryder doesn't complain about it. Next, if has freight. Else gather the freight. Chaos or locked freight. So the freight has multiple sets of values in here, multiple states that it can be in. So it can be in lock on trailer. Lock on trailer means I can't touch it until I actually ram the side of the freight and knock it off of it. It's stuck onto the trailer. But if it's not stuck on the trailer, if it's just hanging off the side of it, if it's fallen off and it's still in the air, if it's actually landing or stuck somewhere, stuck basically means that physics has turned off and it's not moving anymore. So that or chaos. It's in motion, it's stuck, but not following a racer. It's got to be one of these two. Right now, it's only single player, so it's just me, but theoretically, follow racer would mean that it's being used by some other player. And I guess the theory on that is that if I were to ram into another player's freight, it would knock it off the back of their car. But I'm not building for that right now. Now, follow racer, so chaos and stuck is what I'm looking for. Not driver, car action. Chaos or stuck freight. Now, in order to achieve this, I need to be able to determine if there is freight close by me. Now, What's the best way to do this? I was considering before that I should have a system that holds on to it. So I can basically just pass in a single piece of information to that system that then looks through its full list of positions. Now, most of the time, uh, first off, I don't care about freight that's stuck on a train. It doesn't need to be part of that system yet. And so if it hasn't been knocked off of a vehicle, then it doesn't matter. It's just following as a sub object of that vehicle. Okay, so I need a system. Let's go up to the top. I'm going to put a note in. I'm going to put this in the actual task notes. To find the freight, I need a system to manage the freight. I know I was expecting this one, but I don't think I was going to be using it until I had freight truck. Freight truck comes after traffic car, which will be next. Forward a little bit more. Okay, so let's build our system. In this one, it's freight, so I need to know where that is. I'm going to create a freight system. The freight system shouldn't start until something knocks it off the trailer. Control CV, I want freight system. Okay. Get rid of the original freight values. Now, in this case, one thing I like to do in video games when I'm building this stuff is I like the theory of trust. There's a mentality that we put into our code when we're architecting and designing our code, which commonly says, don't trust the other developers to know what they're doing with your scripts. But then there's a separate mentality that if you don't know what you're doing with the scripts you're trying to do stuff with, why are you in charge of putting code into this code? Now, I do put public and private for things that I don't generally want a person to have to think about. So there's a difference, trust versus having to think about it. I expose the methods and the properties that I want them to realize, that I think are reasonable for them to apply and use directly. So for right now, having a freight system in here, I think this is very reasonable. However, how was I going to do this? I need to index a position, but then how do I actually notify that that one is handled? The problem that I'm questioning right now for an efficient system is that I would just have an array or a list, and then I would store indexes. So each one of them, if they update their position, it would have to update the index of where it's related to. But in this case, if freight can be removed from the game. So once freight is removed from the game, then what happens to that? Actually, I could treat the system, I could take advantage of caching. So I would just have a list of 1,000 freight. And if I need that to grow, I'll make it grow. But otherwise, I don't care. I'll keep the full list. So list. Also, there's the separate concern that I'm trying to make this just to get something out there, and I'm not as worried about performance in this one. So list, and this is index, not index. This is vector 3. Positions equals new. Cool. All right, so we've got our positions, index, and if nothing's using that, I would need to know which indexes are actually free. Okay, so I do need to have something to indicate which ones are free, but then how would I do that one? Feels off. Okay, whatever. I need something that works and then I can improve it. Public list positions, public list bool used. And now I need the static singleton state. Public singleton, public static freight system instance, public static, public void awake. These don't need to be public. This would make more sense to be private. I have no reason to execute them. So the titles being available just confuse it. All right, awake. I need to get back into this habit because I'm going to be doing more with solid, or I very likely will be. All right, private void awake. Same thing, these would also be private. Private void awake, and inside of here we're going to say instance equals this. This is also the first point in the code where I am stepping outside the boundaries of continue to replay and continue. Recompile and continue play. In order to solve for that, there was a couple commands that I could put into here, which I don't remember any of them right now. So forget it. I will not support that at the moment. All right. So we've now got that in there. Now we need a public and private field. In this case, an interface would actually be nice. So I'm going to say public interface, and this one is iFreight system. So the point of the interface on this is a mono behavior, and so anytime I call in the instance, it's going to pull up a great deal of different functions, and that's not why people are reaching out to the freight system. That's not a game object they're going to move and manipulate. All right, instance equals this, and this is going to be iFreight system, and over here, comma, iFreight system. Okay, what are some of the commands that I need? I need to add freight. Void int. All about freight. So in this case, we're going to add a freight. Okay, so we add the freight, and it's supposed to return an index. So let's go ahead and add that. Yes. Now for the new freight that we're adding, this is going to say positions. Oh, it needs the position. Yeah, we're going to get the position from the current freight. Positions.add freight. What? Oh, yeah, it's not freight. It's freight dot transform dot position. Next, we're going to say, what is the used? Used dot add true. All right, so that adds it. It's going to be permanently moving forward, so we can skip a whole bunch. We don't know which ones we'll have to skip. All right, let's just do a quick add-on to improve the speed and performance of this. We need to get the current true, the most recent index of true. So int I equals, what is this one? Used dot find first what? No, not first. Okay, first false. He wants a function that tests and evaluates whether or not it's supposed to return true or false. So x, x. What am I doing wrong here? All right, so in this case, let's bring up code and say C# link line Q first. All right, what do we got here? We got numbers, first number, just, no, I don't want first. I want the first where the first is true. Isn't that what this one just did? But I want the index. It's returning the value. I need the index. Okay. Dot index of false. This was much more basic. All right, so we got the index of false. Now, if index is greater than -1, no, if index is greater than -1, equals -1. That's what it returns, right? That it returns -1 if it doesn't have it. Thank you for Microsoft likes to have a set of standards online about how you're supposed to create APIs, how you're supposed to create the libraries and the frameworks. And in pretty much every set of standards that Microsoft has on this, you're supposed to be using XML comments. Just filling it in to explain the purpose, what the point of the values are. So what would be the value that we would get in the case that nothing is there? And I should be able to find that. I shouldn't have to look through their code to figure it out. All right. So index of. C# list index of. Yeah. Index of. But what index of -1? That's what I'm expecting it to return. Index of method. Thank you. Okay, got it. So this one should be a typo and it shouldn't get it. So Tyrannosaurus, it returns a -1, which is out of range. Good. If index equals -1, then I do that, else Add new. So this is only at the points where it actually adds it, which freight coming into play from a car or from a truck that's traveling through doesn't actually get added. It's only the points where we interact with it. Okay, available space. So in this case, we're going to say, what is that? Positions, index equals freight dot transform dot position, and then used dot index equals true. All right, so we re-enabled the use of one of these. Now we add something, we also need the ability to take it away. That's going to be one of the things. It's not technically part of this code yet, but public void, this should be up here. Get rid of from down here, add it to the interface first, and then let that put it in. All right, so void remove int index. All right, in this case, index, we just need to say used index equals false. I'm not actually removing data in this case. All right, so this seems reasonable enough. Now, what is going on here? Oh, I need the index to return. So in this case, if I have an index, I need to return it. Okay, so in this case, we add the index and we're going to reset the index value. Index equals positions dot length count -1. All right, and then return index. Okay, if anyone is ever confused by this, such as the index equals -1, and then I'm changing the index here, and wouldn't that trigger the else statement? The answer is no, and a lot of you probably know that very clearly anyway. But one of the ways that to think about this is that in the assembly, it evaluates the true false condition and then decides if it is true, it's going to send you to the set of instructions that are here. And if not, it's going to send you to the set of instructions that are here. So by the time we get to the end, it's just going to do a go to line effectively coming down to here. A lot of developers are afraid to use things like go to line or go to label, not line, label. But when you get down to the assembly level, that's just built in. And so it's what it compiles to anyway. All right, index int, there we go. That should be done. We can add and we can remove. I don't need a reason for clearing. Oh, now that I've got this, I need to be able to find freight that is closest to me. All right. Public int find freight. Oh, I should actually store a reference to the actual freight. I need to get the real freight. So private list freight. Now, freight is a word that is plural on its own. I wouldn't say freights. So equals new, and that makes it a little confusing as to whether or not freight returns to refers to an instance or an array or a collection of some type. All right, now in this case, we're going to add this. So freight dot add freight. Okay, on the other one, we're going to say freight index equals freight. Okay, now the expensive part of what we're doing is that when we're clicking the action, we need to actually search through all the items and find the closest freight to us. And this one's going to be called potentially every update, because it's not just when we press action. I'll very likely want it to highlight as we get close. All right, so public find closest. So that gives us the index. We're also going to want to return the freight. In this case, I should just, do I have a reason that I need the index? And the answer is I don't believe so. I just need the freight itself. I don't see a reason why I would need the index, why I would need to go get the position from here as opposed to just getting it from the freight that I'm going to be interacting with in other ways anyway. All right, find closest. So now we need a vector 3 world position. Yeah, if I'm using position, it should by default be understood world. All right, find closest. Now in this case, I need to go through all indexes of used and vector 3. Now, because of the fact that I could have intermittent removal of items, I don't necessarily want to, I would say that I wouldn't want to check all the positions, but I'm going to get a performance boost by checking them because most likely it'll be sparse for the ones that are actually removed. It'll happen, but it'll be on occasion, rare occasion compared to the number of cubes that are likely in play in the game. All right. So we find the closest position. So now we're going to say for int I equals 0 to I is less than freight.count I plus plus. All right, now inside of this, we're going to use each of these values, which is I need to pull each one of them. If I'm pulling each one of the values, then the code or the CPU is going to get the fact that this instruction, every time I come here, jumps forward the exact amount of space in memory. And so it can start prefetching stuff and run faster when this is a larger list. All right, so for int I equals 0 print count. Now I want to get the values. These are stack values, so they're going to be really fast to use and get rid of. I could store them and keep the memory, but big deal. Int, let's see. For this one, I need 3 different references. I don't need the game object. I need two references. I need used and the freight. So int used, int u equals used I. Oh, bool. And then vector 3 freight. Let's see. F position equals, or freight position equals this one. I don't want to go through the freight. I want positions I. Okay, so this obtains the used and the position. Now I'm going to say if used. All right, so if it's used, then that means we can evaluate the distance. We do need to know what the closest position is. So I'm just going to store the, in this one I need a float, float, and we're going to call it square distance, SQ dist, equals float dot max. Okay, so now I want to find out the distance between two positions. This one is used, so it's an active point in memory. And now I'm going to say if what is that? Vector3 dot position, no, dot square magnitude. And for that one, I need a vector, which is going to be position minus F position. It really doesn't matter which one you which order you subtract them from. The distance comes out the same, or the square magnitude comes out the same. Oh, I forgot an I. Okay. Now, is this greater than? What time is it? All right. If this is less than SQ distance. Oh, I need the value. So let's just get the value from here. Float SQ dist magnitude equals that one. Now that I've got the value, I can say if SQ mag is less than SQ dist. So at this point, we know that we are within the range that we want. And the only thing that I need to do is store the new distance. No, I have two things I need to do because I need to get the current index. So int current index equals -1. So current index equals, and that's going to be I. And then the SQ distance equals SQ mag. All right, so we effectively go through every single thing in the array trying to find it because we can't sort it. There's no three-dimensional memory to sort it and just pinpoint where that's located in memory. All right, so now if current index equals -1, return null. We have no freight. Otherwise, return the current index. Let's see if that picks up on here. There's now sounds going on in the background, so I'm checking my audio. It's not picking any of it up. That's good. helps if I can type. Okay, so now I have a freight system. I can add items, I can remove them, and I can currently find the closest freight to me. I should have an output of the distance too. Let's do that. Out float distance. This is something, if you don't, I remember struggling with this mentality a lot. The way code is written inside of C sharp, inside of most languages, you have one value that's going to equal whatever the output of a function is. And there's this mentality that you only want it to return one thing. But what if there are more, is more than one thing? Do not be afraid of having an output parameters in there as well. It's a little bit awkward to write sometimes, but it makes it so much more performant than having to call multiple sets of functions. Having to need something to look up another thing in a list in memory somewhere. So in this case, if we are returning the freight, we should also set our distance. That'll be happening down here. So our distance is mathf dot square root of distance. What? Oh, square distance. Return null. Distance must be assigned by here. Okay, so at this one, distance equals 0. Distance doesn't matter at that point. We just need it set to a value. Can I preset it to a value? No. All right. So that gives us our output. We know the distance, how far it is. I should put it in another thing just to say what the maximum distance is. So float max distance. Now inside of this, I need to modify that. So max distance equals times equals max distance. So I'm turning this into a square magnitude right away. That way I can do another check. If sqmag is greater than max distance, then continue. So we don't need to check anything that's beyond a certain distance. So the action button should only relate to things within a certain distance. We have to be able to see the object. All right, so now I think this freight system is done. We have a freight system that stores this. Now we need the freight to actually put its information into there. All right, so this does not happen on construction. This is going to happen on set chaos, or also when we are setting it to stuck. Where do we set this to stuck? There. So at this point, it could be inside of there. Oh, no, no, no. As soon as we go to chaos the first time, that's where we set our index. And then any point that we update, we should be updating that value as well. All right. Private int, what is the value? We need the index. I'll put it as public for now. No, private int, freight index, system index equals -1. All right, so we got the freight -1 index. Now we've got the point set chaos. That is where it can start entering the world and having its value set. Oh, I do need this value to be serializable. I need it serialized from my side. So let's just do this. System.serializable. Why is this complaining? Oh, well, oh, it's serialized field, right? Now, where is this? Is that Unity? Yeah. So we serialize the field. That's marked in Unity. That's not something that I get access to when I'm saving. I know that I'm going to want this in my save games later, so I'll just mark it as internal. I don't need it serialized. All right, so chaos. Set chaos. This is the point where it jumps into there. All right, so inside of set chaos, we need to get its value to begin with. We're going to say there are different points where we can go back to chaos. So let's see, trigger chaos will also set chaos. That's where we are stuck, but then we activate the object again. All right, so chaos, let's get the index. Oh yeah, if it's being dragged by something, then it doesn't need to be in the freight system. The freight system only cares if it is available for interaction within the world. Otherwise, the object is self-contained and I'm using Unity's default physics to deal with how it interacts. Okay, so anytime we set it to chaos, we need to get that value. So the first thing is we're going to say if freight system index equals -1. So at this point, it means the freight system does not know who we are. We're going to say freight system index equals freight system dot instance dot add this, and now we get the index back. Okay, great. Next, if we are going into the stuck phase, I want to create a function for this. Now, as far as I'm aware, inside of Writer, it does not have the capability to just right click and send it to a function. What is this? Maybe this does it? Well, let me do a search on that right now. In Writer, can I select code in a function and have it automatically extract it into another function? Visual Studio can do this, and it's incredibly useful because it converts any variables that need to be passed through to it into its own parameters. Okay, it claims it does. So let's do this. Right click has a refactor. No, okay. I think it was interface, but maybe not. Maybe this has been in here. Oh, okay. It does it through a UI. Okay, I think I ran into different issues. Maybe this is improved from what I had before, but I didn't like the experience. Okay, so now let's see. States.stuck. In this one, we are set stuck. Next. Okay, it's set stuck. This should be setting it to stuck. Excellent. At this point, we need to now say, where's that? The code was freight system dot instance dot remove, and now we're going to remove ourselves from this list. Freight system index. After that, we're going to say freight system index equals -1. This.state equals states.stuck. Okay, that resets our state to stuck. It gets rid of us from the freight system. And now we also need, anytime that we're setting this information in here, we need to get that information back over to the freight system. Huh. Now, inside of here, I am using a previous position variable. But if I'm going to be accessing another point of memory anyway, where I have to get that value of where we currently are, then it's reasonable that I can use this. I don't need previous position inside of here. All right, let's take advantage of that. Okay, so the first point is when we set the chaos, we get the previous position and it equals whatever our current position is. Okay, but in this one, when we're going to set chaos, we are adding it, we are getting this system index, and it's going to extract out our position. I just need something from there to obtain the position. So let's go out to the freight system, add, and let's get position. So public, you know what? No. This doesn't really give me any major benefit. I'm still going to have to interact with it, but I've jumped into this class instance, so it already has these most likely pulled in. The CPU doesn't have a reason to jump very far in it, but variables that I know I'm going to be using a lot. I'll be using these values quite a lot. That's it. Okay, yeah. So those ones, and then we also are going to be checking the state on those. So this is something to consider when you are engineering what values to go on top. A lot of people say you should have all your public stuff on top, your private variables in the bottom, your static instance variables above the public ones. I disagree with that. When you load an instance of your object into memory, it has a certain amount of that memory that it can pull up right away, a cache line. So 64 bytes of data. Now, what things are you going to be using most often inside of that? Am I going to be pulling state almost every single frame? And the answer is yes. So where's that? I check the state every single frame. So no matter what I'm doing, every single frame, this is happening. And it's not just frame, that's fixed updates. So potentially more than once per frame. All right, so inside of here, we have we're updating that, but then we also are working with the position. We aren't using the position if we're not in a state of chaos at the moment, at least not for that one. Okay. I'm gonna undo that part. Gravity normal, I don't need as much as previous position or freight system index. So I want to store these pieces of information up here. I'm basically just putting it in order to say for that first 64 bytes of data that are going to come in for the memory, what should I have available most commonly? And that way, when it pulls it up, it should sort these in order of hopefully the order that I actually put in here. The compiler could make choices to do other orders, but I think in C# it actually follows the way that I put this in here. All right, so we got freight system index. What? Oh, I got freight system index twice. Oh, and I've got the gravity normal and previous position in there twice. Okay. First 64 bytes cache line. Okay, then we've got references on other things, and if it needs to, it'll grab this. Now, when you see car, it doesn't mean that you have all the memory of car sitting there. It just means you have a pointer to where that memory sits. Float will be there as well. Once I go past that first cache line, I'm not as concerned unless I go through my code and kind of evaluate which ones am I using every single frame. I don't see any reason why the C# compiler would understand that update or fixed update gets called a lot. Generally, the compilers are only going to look at a couple lines of instructions and see how those relate to each other and can it reorder some of those. Okay, so we'll leave that. This one should be done now. We've got freight system. We get rid of this when we move into stuck mode. Perfect. This one is also supposed to have the follow state, follow racer, and that's going to be activated in this time. We need an anchor where it's supposed to follow. So transform, do we have a transform where it follows? And no, I do not. So I'm going to say public transform anchor, racer anchor. So the racer anchor is a point that's going to follow at the back of the car where the cube will then try to stay at that spot. Okay, also if it's stuck, it should be rigid body off, kinematic. So kinematic means that the physics on it no longer do anything. It just takes updates only when we give it code to move it. All right, so now we also need, what was the other one? Set anchor. Public void set anchor. No, what was the term that I have? Follow racer. And from this one, I do need the anchor that it's going to be used. So transform anchor. That is another thing in Visual Studio when I'm typing in transform and I forget to put a capital T on there, so I only have the capital transform. Visual Studio tends to realize that I'm typing in transform, and when I hit space at the end, it still does its IntelliSense autocomplete. So that means if I had a word, the similar word to it, it would type in that word. Now, it does mean that I can't type in new magic stuff ahead of time if it's closely related to something else. No, I think there was something different, but whatever the case was, that felt better in Visual Studio. However, I'm not using Visual Studio anymore. Or at least I'm trying not to. I still have it installed on my system. When I installed Writer, I turned off all the AI stuff, so it's not doing any suggestions. I've been finding that way too distracting. Okay, so next, transform anchor. So we're going to say anchor, racer anchor, yes, equals anchor. And we also need to set the state. So this dot state equals states.follow racer. All right, now if we follow the racer, at this point, that's technically all that we need to do. However, if we're following the racer, we are no longer in the system, in the freight system. Let's put these there. This will have, so right now, this is a complexity that I'm putting into the design. If I decide that I want to change the design to allow a person to press the action button to just steal it directly off of a truck that's carrying it, or another car that's carrying it, then I would have to come back in here and reestablish how the logic of this works. Because then the freight system would need to be aware of it when it's inside of those places. But then that also means that I've got all these movement updates that are happening when it's in control of a car that still need to get updated back into that system. But I shouldn't need that normally. All right. Oh, that's right. I'd still need the update, its position to get updated into here. First off, when we add ourselves to the system, it adds it, it takes the position that we have. Next, on all of our fixed updates, we're going to say, where's this one? We need to update its position. Oh, do I have a command in the freight system to update the position? I do not. Okay, so public, nothing. Void update position, int index, comma, vector 3 position. Why did it, what? Wait, what did it just do? What was that? Oh, remove unused method, not what I want. Control D. Implement missing members. There. All right, so in this case now we're just going to trust that the data exists. This is part of the operation where or part of the mentality where I'm talking about trust. If the rest of my code is working, then I shouldn't need to do any safety checks on this. If I'm interacting with an external system like the file system, expecting data from over the network, then that makes sense to do extra validation steps. But then consider a logic to it. For instance, if you make a web request and you get a non-error response, the status is a non-error, it's a 200 or whatever it is, then you should theoretically be able to trust that the data matches the type you're expecting. All right. So update position, find closest. Now, if your code fails silently, then that's a problem. If your code is going to log any of the exceptions that happen inside of Unity anyway, then whatever. You don't need to do separate log messages because this is here, or put in something to trap and capture that. It's just going to do the exact same thing anyway. All right, so that is positions index equals position. All right, so we've updated it. We knew the exact index in memory to go to, so that's about the fastest way we can reach that specific spot in memory. Okay, so now we need to go to the freight. What was this one? Previous position. This is freight system. Dot instance dot add. No, dot update. And this one is previous position. Oh, it needs the index as well. That one. Okay, so freight is working, maybe? What else was needed in here? We've got the freight system. It needs to follow. On this one, we do need to check to see if the state is where we actually need it to be. So if it was in chaos, then we're going to keep it there in chaos. So nothing is set to use this yet. There is no interaction in the system that tells us when to use it. So it's the car action that I'm going to need to get back to. But the freight itself should be responsible for following it. Freight system index, nothing new. There's nothing else for it to do once it's inside of here. Okay, now if this dot state and in this case we are in follow racer. Okay, perfect. So if we're in follow racer, then we just need a lerp speed. I'm just going to use a lerp to begin with, see how that one feels for it. Public float lerp. I'm going to put this up near the top. What do we have up here? State, that's 4 bytes. Int, that's 4 byte. We're up to 8. Gravity normal, that's using 12, so we're up to 20 bytes. Gravity force is another 4 bytes. That's 24. And now another 12. We're using 36 bytes. Okay. Public float lerp. Follow lerp speed. And its initial lerp speed should just be, let's go with 0.5. So it takes it about 2 seconds to catch up with the actual position of where it's supposed to be. No, it feels a little sluggish. Let's go to just 2 for now, a quarter second. Next, when we are inside of here, when we are setting to follow racer, we need to reactivate the gravity system. So in this one, the gravity system is also being applied because I want the gravity to try to sink it. No, I don't need the gravity to try to sink it. It's supposed to act like it's floating. But I will turn on kinematic. So body dot kinematic equals true. Oh, not there. No, it's false. I want to make sure it's false here. All right, so, set chaos. I want to put these functions together because they all operate in the same space. All right, so set chaos. We set the parent to null. The parent, do we need the parent to be set here? No, no, the parent is not set to the player vehicle. Oh, that's going to be a problem for stealing freight from other players later. not a that's not a problem inside of the current technology set. So, our current requirements for the game, ignoring that. All right. So next we have the player, we have the state, we chaos, this collider trigger. Body is kinematic, false. Add explosion force. Okay, we've got that. Didn't matter. Gravity normal. We've got the car's gravity normal that we're applying to it. We don't need that information right now. Oh, when we set to chaos, we're checking to see, does it have a freight index? We're pairing that one. We are assuming in the first setup. So when I first made this code, the set to chaos, that was from being on the back of a truck. Now the truck, it just was a child object. It didn't have its own physics. It just stayed with the truck. If the truck turns, it turns. Now the physics are turned on, or whatever state we're getting this from. Originally, we were expecting to take it off of the truck, so we set the parent to null, but also it had a car, and we were trying to get its gravity normal. Yeah, right there. If it's got the car. Now, the car, in this case, this is not the right term for it. Train car. No, this is actual car. Because it has an actual car that it's getting a gravity normal from. In this case, it will also have a car. So the truck, each element of the truck that can float around has a car. The car is basically, I guess, more of a hoverboard. Ooh, that might be a better term for the class, a hoverboard. I'm not going to change it at this point, though. Where is that? I'm going to go into car, and I'm going to put a little comment in here. Hoverboard. This doesn't actually handle making the car move forward. All it handles is stabilization. When additional forces are being applied that tell it the object to move farther, which this does have functions for, it will do that. But otherwise, wherever it's dragged around, it'll just correct itself, which that can be kind of fun to experiment with at times. This is not functional yet, is it? That doesn't matter. I'm going on a tangent. This is a big problem. I run into tangents all the time. All right, remove. That's freight system, car action. No. We are in freight right now. Okay, so set chaos. Just double checking. We are expecting the car to be there. And we grab the normal. The only time that it's going to go from stuck, the only things it can go to chaos from is stuck, or it's attached to a car or a vehicle. Okay, so if I set to chaos, I can't set it to chaos from stuck. If it is stuck, that means the object is sitting there and it's supposed to act like a stable piece of the environment at that point, which is why we set kinematic to false. Oh, in stuck, we set it to false. Okay, so it doesn't really matter which one it comes from. It will have a car. And so setting to chaos so far works. This dot collider is trigger. That's based off of if something else bumps into it, then we can do this. I wonder if that means if I back into it, that it will knock it off of my own car. That'll be kind of fun to test, I guess. Oh, if it gets stuck between me and another object, like I back into a wall and I've got the freight right behind me, I'll back into the cube, and then that will basically knock it off of my control. And now when that gets knocked off of my control and it goes into chaos, that also means that it's going to have the rigid body turned on. The collider will have the force to realize, hey, I'm colliding with these different objects, and it'll try to push itself out. So you have the cube bounce and fly away or fall down, whatever it's going to do. So this, I think that's set chaos. All right, so now follow racer. When we are in this, now we need the cube to actually move over to the racer. So that was basically just lerp. The physics are already turned on. We're just going to keep them on. And now, where is this? Lerp speed, follow lerp speed. Body dot position. I'm just going to set this through the transform. Actually, I don't know if I should set that through the transform or through the rigid body. I wonder if I don't know if there's a difference as to why. I would have assumed that the position, that the transform would have would have just used position from the transform, or rigid body would have used position from the transform, but it has its own. Why? Okay. In Unity C Sharp, why does rigid body have its own position? Why doesn't it use why doesn't it use muted transform dot position? Allows you to get and set the position of the rigid body using the physics engine. Okay. If you change the position of a rigid body using rigid body position, this transform will be updated after the next physics simulation step. This is faster than updating the position using transform position, as the latter will cause the attached colliders to recalculate. Okay. All right. It makes it faster. Good. So in that one, I'm going to say body dot position plus equals. No. Equals lerp, vector 3 dot lerp. Oh, I like that. I typed in lerp and it corrected it to vector 3 dot lerp. I don't remember seeing that in Visual Studio. So +1 to Rider at the moment. I'll have to look. I was going to say I'll have to look that up and compare it, but I don't care to look that up. Body.position.lerp, vector3.lerp. And the lerp that I want to go to is from its current position, body.position times, no, not times, comma, its second position is going to be where it should be. That's the anchor. So in this case, I'll just say this dot anchor racer anchor. And now it needs the lerp variable. Whoa, not all of this. Lerp, follow lerp speed times time dot delta time. But why am I getting a complaint? What is lerp speed? It's a float. Oh, that's a transform. Dot position. There we go. Okay, so we're basically just going to have it start lerping to follow. Now we need an action to trigger this, and that's going to happen over in car action. That's the final part that I need to work on. So here, has freight. Do we have freight or do we not have freight? I suppose in the freight we could hold on to information about the car, but we don't need to. We already do. It holds on to a reference to the car. Okay. So if we have freight, we need to release it. If we don't have freight, we need to see if any is close by. So first off, we're dealing with, do we have freight? If we have freight and we just press the action button, we need to release the freight. So in that case, then I'm going to say freight dot set to chaos. In this case, it should already have the car set to so when I set it to chaos, that means it releases. We have pressed the action button. It should release it. Okay. Next, we don't have any, so let's see if we can grab one. I will want to upgrade this later, most likely to have some signal to indicate that there are cubes or freight that we can pick up, and probably a visual highlighter to indicate exactly which one it wants to pick up. Basically just whichever is close enough. We need a distance to determine how close we can be. So in that case, this is fields. And I'm only going to use this. I'm checking whether or not freight is null. And so I have a pointer. It would get a null pointer. And so the null pointer is what, 8 bytes? All right, so 8 bytes for the null pointer for freight. So that's fine. That should be right up at the top. I'm using that all the time. Control X, paste it there. This again is cache line 64B. On input has freight. Okay. Are we doing anything with car? We do have action performed, but we've put that work onto the input action. It'll call our function at the point that it needs to. That's only when something was clicked. Otherwise, updates, we don't need an update here, at least not yet. Maybe we'll have one later. We just need to know what to do when we get the action. Okay, there's not much to do here. So in this case, we need to find out if there is freight at the time being. So that's the freight system. Freight system dot instance dot didn't I have, oh, I think I created that. Was that find closest? Yeah. Let's take this whole line, Control C, and that needs to be part of this. Our action, find closest. Oh, we'll be setting it because we're using it. Freight equals. Perfect. Okay. Find closest to my position, and that is transform. I'm in a mono behavior. Oh, I forgot the end. Anything else? Max distance. This will be something we can update. Public float max freight distance. And in this case, let's say it equals 20. So 20 up to 20 meters away from the car. The car is 3 meters long or 6 meters long. I think it was 6 meters long, 2 meters wide, and 1 meter tall, or 1.5 meters tall. So that's about 3 times the length of the car. That should be fine. Transform.position, and so now we've got max freight distance. And what does it have? Now we need an out distance of how far away it is. I don't need that, do I? I'm giving it the range, and it's finding the closest one. Do I actually need that output? I don't think I do. F12. All right. What I'm going to do in this case is I'm actually going to copy this and duplicate the function. And on one of them, I'm going to remove the extra stuff. So there, don't care. There, I don't care. That is it. Now the only other item is duplicating that on the interface. And removing one set. There. I've got the other one. If I never use it, fine. Remember that when you compile, Unity is going to, by default, remove any superfluous functions, any functions that are never called, any variables that are never used. It just removes them. It doesn't get compiled in. It doesn't sit in memory. It's as if it never happened. Oh, I have nothing going on there or there. Let's get rid of those, or system. Okay, car action, find closest, and I don't need anything more than that. It just finds the closest one with a maximum freight distance of here. That sets the freight. Now we need to say if freight, if not freight, return. There's nothing else to do at this point. There was nothing close by to use the action for. Otherwise, we have freight, so it's freight dot set follow racer. And now at this point, it wants information, right? What information did you want? The transform of this one. I need an anchor. All right, so that anchor, yeah, sure, I'll put it here. Public transform. This is an object reference. Wait, transform is a struct. Transform is a class. Okay. Public transform anchor. What is this one? This one is a freight anchor. Okay, that sets it to now follow. So I think this is all set up now. That's all that this one had to do at this point in time. And I just need to set up some of the stuff in the game's UI. Has this started to compile in the background? It already did. Nice. Okay, I do like that about the connections to Visual Studio and Unity and Rider and Unity. That you save it, it automatically does it. A lot of times it's not until I get back into Unity that it actually starts to check that and say, oh yeah, I need to recompile. Okay, any errors that is complaints? No. All right, so let's start checking out these objects. First off, I have freight. Let's put the freight as a child of this. Okay, so it's locked in place. It's on here. The freight should have a reference to this car, yes. The rigid body on itself, and the box collider on itself, yes. Now, anchor transform, it has nothing. Okay. Now for the car, racing car. Oh, this isn't car. This should be trailer car. Now, if I'm changing that, it should be trailer car and trailer caboose. Which also means my names in here should change. So I don't add more like that. Okay. What? Oh, it's not trailer caboose. I started typing that one in trailer car. All right. No. Control S twice to save the scene and project. Now, where's my car? My car has different states. Wait a minute, doesn't the car have an input state? Or the new action state? That was a new script, wasn't it? Car action. That goes down here. All right, so car is, oh, that's car driver. Where's car? There's car. Freight anchor has nothing. Freight has nothing. Those are fine. The input action. Why is input action a plus? This is what the normal input actions look like. Dude, I still just drag it into this and it'll convert into something like that? Okay, well, let's see. Do I have an action? I'll go with attack right now. What are these ones? What's the type difference I'm using? Input action reference. Okay, I probably need to make a small code change. Let's see. Input action reference. Okay, yeah, performed is gone. Dot action dot performed. Okay. Theoretically, I think that's set up now. And that should change the type of field that I have here as well. Oh, that looks much better. All right, so we'll go with attack for the moment. What is attack anyway? Input action has attack. Save that to make sure that we're in there. Let's go see what attack is. So attack is currently a button, mouse pad. What's my keyboard? Keyboard, enter. Okay. Oh, I need the systems. Do I have any other systems in here? Actually, I'm going to close this one out for now. I'll probably come back in a few minutes, but I'm going to take a break for a little bit. All right, I'll see. I got to go check some stuff. So I'll see you guys later.